Hello, good morning, everyone.
Good morning.
Morning. Good morning. Yeah, just give me 1 minute and I will start. Okay. So yeah, my name is Puneet Pandey. I have close to 12 years of experience and close to 5 years of teaching experience in machine learning. Um the stats and machine learning modules, the combined module, stats and machine learning. In total, we will be spending close to 70 hours on this, right? Uh, First, I would say 30 hours we will be approximately, right? We will be spending on stats. And then the last 40 hours we will be spending on machine learning. Okay. Now, before we start, right, there are certain things that I want to talk about. Let's say, for example, right, there are other modules as well. Let's say, for example, Python is there, SQL is there, your Tableau is there. I believe that those are comparatively easy as compared to stats and machine learning. So that doesn't mean that the stats and machine learning is very tough. I'm just saying that those are comparatively easy. Okay. But when it comes to stats and machine learning, it takes some time to absorb. Okay. It sometimes happen that whatever happening in the class, you might not get it in the very first time itself, but if you will revise the same concept again, right, it helps you absorb it. Okay. It's not like SQL or Python or Tableau where um, you know it, there can be only one meaning out of it. Let's say, for example, 1 plus 1 is always 2. There is no ambiguity around it. There cannot be two different point of views around it, right? But in stats and machine learning, it happens a lot many times that it depends upon the receiver as well, right? That how he receives the information. Okay, there can be multiple ways of presenting the information at the same time. There are multiple ways in which someone can perceive the information as well. Okay, so things are little bit subjective in stats and machine learning, and that's what makes stats and machine learning a little bit more interesting as well, right? Now, let's say if I had to divide stats and machine learning in 10 chapters, I feel that out of these 10 chapters, 6 are actually very easy. Like very easy. Like what is average, what is median, what is standard deviation, right? Things you might have heard even in the 7th, 8th class mathematics as well. Okay. So I feel that 5 or 6 chapters out of this 10 chapters, you will find it very easy. Okay. Around, I would say, 3 chapters which will be there, which will be, I would say, of a medium level difficulty. If you'll just pay attention in the class, you will be able to grasp it. Okay. And then maybe 1 chapter out of the 10 will be a little difficult where you need to focus in the class as well, and maybe go back and like read a few articles by yourself as well to get some understanding of it. And then 1 out of 10 will be a chapter which might take you, maybe you might not understand it now, you might not understand it even after reading online, but you might understand it 2 3 months down the line. Okay. So, but where the problem happens, right? Like if I'll go by this split, the split that I was talking about, right? So what I was saying is that, let's say if there are 10 chapters in your stats and machine learning, I really feel, right, and I'm not making it up, I really feel that, you know, 5 chapters out of this is like very, very easy, which makes it like 50% of our course, right? It means that if someone will be attentive just in class, right, not revising anything, not reading anything, or uh, not focusing at all after the class, even then you will be able to grasp 50% of the course, right? Then there will be 3 chapters which I feel is of medium difficulty. That is like 30% of the course. Okay. In which, if you will be attentive in the class, right, believe me, you will be able to grasp most of it. Okay. There will be 1 chapter which will be, I would say, hard. Maybe you need to focus in the class as well. Maybe you need to go back and read a few articles as well. Maybe watch a few YouTube videos, XYZ things. You would have to put effort to understand it. And then I was saying that there will be 1 chapter which will be maybe very hard, which I believe most of the students have like very hard time grasping. Okay, sometimes the mathematics is hard, sometimes the theory is hard, but I've seen people struggling in 10% of the course. Okay. Now, where the problem is not that this 50-30-10-10 split exists. The problem is that it is not linear. It means that it will not be like that if I have 10 chapters. Let's say these are the 10 chapters that I have. It's not like that the very first 5 chapters that I will be covering, that will be very easy, right? The next 3 chapters that I will be covering, that will be of a medium difficulty. Last one will be, let's say, of a hard difficulty, and this will be of very hard. It is not like that. And that's what the problem is. Okay. What happens is, it might be something like this, that this will be like very easy. Then I will have a medium difficulty one, right? Then again, a very easy one, right? Then I will have a hard chapter. Then again, I will have 2 chapters of very easy, maybe 1 chapter of very hard, right? And again, let's say maybe 2 chapters of medium. This is what the problem, where the problem lies, right? What happens is that the people start attending the classes, right? They will like it first class, very good, right? It was easy. I think I can do it, right? Second class, again, very nice, right? By the time they reach the third class, they realize that, okay, yeah, no, there are few things that I need to focus on, right? I need to put like a little effort to understand it. Then again, you find it easy. And then again, there will be 1 chapter which will be very difficult to grasp. And I've seen that because the people are not being able to understand this particular chapter, which is very hard to understand, right? They don't even continue with the course. Like right now, you might feel like that, okay, I'm not like that kind of a person, but I've seen this happening with a lot of people. Okay. Whenever there is a hard chapter in between, and if you are not being able to grasp it, I've seen that a lot of people don't continue, right? Thinking that the difficulty graph will be like this. That if I'm not being able to understand this, it means that the coming chapters I will definitely not be able to understand. Okay, but it is not like that. There can be a few chapters in between that you might feel that you are not being able to grasp, or you're finding it difficult to understand, right? But if you will be disciplined, if you will be attending the classes regularly, you will realize that maybe that chapter was difficult, but the next 2 chapters were again very easy, right? So anyone who will be thinking that the graph is like that of difficulty, he might only be able to learn till here, this much only, right? Because after that, he is not being able to move because he feel that this chapter is very hard. So coming chapters will also be very hard. But anyone who will be, I would say, uh, uh, disciplined and like attending the classes regularly, right? Even if there are like few chapters in between you are not being able to understand, but first you were able to understand, second you were able to understand, third, fourth, fifth you might not be able to understand, but six, seven again you were able to understand, right? Eight you might not be able to understand maybe, but nine you were able to understand, right? And as the course will progress, you will also become more and more mature in your understanding of stats and machine learning. So when the let's say I reached here, hypothetically I've reached here, but I was able to grasp only these chapters, but there are like a few chapters I was not able to grasp. Now, if you will go back and try to attempt these chapters again, you will find them relatively easy. Okay. So the point being is of all of this discussion is be consistent in the class, ask question, revise things, right? And even if there are like a few patches where you feel that you are not being able to understand something, first of all, put extra effort if you're not being able to understand something. Ask me questions. Maybe I will take more examples, better examples. Okay. But even if let's say worst case scenario, you are still struggling, then wait, right? Focus, don't use your phone in the class, right? Focus, try to understand it. Believe me, maybe that chapter was difficult, but the next chapter onwards, again, you will be back on track. Okay, so this is a very important part. This is going to be a long module, right? We have close to 70 hours of course divided by 3. So it will be approximately 23 classes. 23 classes divided by 2 because there are 2 classes each weekend. So you will find that I need to have close to uh, 11 weekends. Let's round it off to 12, right? Assuming that there are 4 weekends in each month, there is going to be 3-month long module. It is going to be a 3-month long module, right? But again, if it was very easy, if it was very short, everyone will do it, right? And there will not be any value in it. Okay. But I can guarantee you one thing, right? In the next 3 months, if you will stay with me, believe me, your stats in machine learning will be way better than most of the people who are out there. Sure, Purva, we'll cover everything. Application, use, everything. Okay. Yeah. So yeah, that was all. Another thing, before we proceed, um, I hope Python is covered for everyone who is attending these classes, right? Um, if your Python is not good, my suggestion will be, right? My suggestion will be the first few classes, you will find it relatively easy. There will not be much to revise. So please revise the Python. Python is a very important thing that you should know if you want to make your career in this. Although, right? Although I myself is not a expert of Python, right? And you will realize later that for using stats and machine learning, actually you do not need to be an expert in Python, right? But we will start with this understanding that you need to be very good at Python, right? To do, we'll just like assume that, although that is not true. Okay, we will just assume that the Python and everything is very important for this course. And at least for the first few classes, when the classes are like very easy, right? Try to focus on the things you have already completed in the Python. Try to kind of become better in that. Okay, practice it more. It will definitely help you in this course also. Okay, any question before we start?
Puneet, hi, and this is like, can you hear me? Hello.
Yeah, I can hear you. Hello.
Are we gonna give like 3 months purely on stats, or are we gonna like cover other mathematics like topics like linear algebra or calculus?
No, first of all, calculus and all like high quantum mathematics we are not doing. Uh, there will be a small part where I will be covering integration and differentiation. Okay. Very small part. Okay, which is I mean the basics of machine learning that we will be covering. We will be
Okay.
spending one class on that. And this 70 hours is the combination of both stats and machine learning. In general, it is 30-40. 30 hours on stats and 40 hours on machine learning.
Okay.
Okay, and in between also we will do some math.
Okay. Okay.
Okay. Any other question?
Yeah, what are the prerequisites here? Python is only the thing we need to know,
Yeah, the
or
only thing that's the only thing,
okay, okay, thank you.
right? To be very frank, even if like your Python is like very basic, like 3 out of 10, even then it will work, right? But I will always suggest that try to kind of make your Python better, right? Not from just ML perspective, but in general. In machine learning and all, you will not be needing expertise of Python, right? But in the data science field, in general, you will be needing like your Python should be good. Okay, especially like someone asked like which topics, especially the NumPy and Pandas. NumPy, Pandas. These two module you should know by heart.
Yeah,
Hello,
thank you.
Pune sir. Like,
Hmm.
do visualization libraries play a part here? Like, are they important too?
Right. If you can at least have basic idea of matplotlib, that will also be better.
Okay.
Okay, but if you know these three, NumPy, Pandas, matplotlib, I feel that you cover 80% of what is required in this field.
How about Seaborn? Like, it was covered very
Mhm.
basic in
Mhm.
our Python classes.
No, so like see, like whatever is covered is actually important, right? I was just saying from a priority perspective.
Okay.
Okay, so any visualization library, if you want to use Seaborn, that's also fine. Matplotlib, that is also fine, right? But any visualization one that you should know, at least one.
Okay.
Right? If some data is given, if someone will ask you to create a bar chart out of it, it doesn't matter how you are creating it, right? Which library you are using it, but you should be able to create that. Okay, now let's start. So with stats, right? With stats, actually, most of us, when it comes to stats, we feel that statistics is nothing but analyzing data. Okay, but stats is just not analyzing the data. It is actually from the very beginning itself of the data, like the collection part of it, like from there the statistics start. It involves collecting data as well, organizing data as well, and analyzing the data as well. Like all the three parts related to the data is covered in stats. So I feel that anything that you do related to data, that is part of statistics. Okay. Now, what do we mean by collecting and organizing? Right. Let's try to take an example. Okay. Let's say when the Amazon was very small company, right? Maybe they were getting 2-3 orders in a day, and then they finally grew a little. They might start getting 10 orders a day. Then they grew a little bit more. They start getting 100 orders a day. They grew a little bit more. They started getting, let's say, 1,000 orders a day. Right? So when you are getting very few orders, let's say 5 orders, 10 orders a day, to be very frank, maybe you don't need statistics at this point. But when you start growing, right, when you start seeing significant volume, the first thing that the people think about is collecting data. Okay. So let's say if we are Amazon, okay, if we are Amazon and we have seen that our stars, our company is doing good. Now they have suddenly like started getting significant orders. Okay. And now what we want to do is we need to start capturing the data because we want to organize ourselves. And it is not possible to organize a company if you don't know what is happening in that company. And you will not know what is happening in a company if there is no data available. Right. So we are not capturing any data as of now. So we have thought, okay, from today onwards, right, let's try to start collecting data so that eventually we can start analyzing it, right? So that we can make strategies based on that. So if you are Amazon, right, and you have not collected any data till today, right? So what will your first step will be? The first step will be, right, that I will sit down with my team and I will ask them, what are the different variables that we should start collecting? For example, someone might say from my team that, okay, we are having that meeting. And I asked that, okay, we have hired this data engineer and we need to tell him that these are the variables that you should start capturing. Okay. And he will create an infrastructure around it to capture those variables. But we need to give him that list that these are the variables that we need. So what are the variables that we will ask for? Maybe we will ask for name of our customer. Maybe we will ask for, start capturing address of our customer, start capturing email, phone number of our customer. Similarly, what else I will be needing? Let's say if you are Amazon, what else I want to capture?
His orders.
Like order ID, for example, right?
Order ID,
What else?
Time
Order
of
value,
delivery.
delivery ID,
Do they need the order
name.
as a Prime member? Do they need the order early?
right? Very nice. Like, say, for example, let's get delivery
We can
date.
also add on the delivery ID.
Mm-hmm. Let's say we can get delivery date. We can, very nice. Someone said product ID. So which product, which product that the person has, the customer has purchased, right? His frequency of return, very nice, Aman. So, like frequency of return can be, let's say, something which can be calculated from the given data. We need not to capture frequency of return, but if I know for each customer when he has ordered, then I can calculate the frequency myself, right? Very nice. You have also asked for like we can capture the reviews, right? Maybe we can look at shipping charges, like delivery fees if there is any. And then there can be some other type of variables as well. Let's say uh, transaction ID.
Mode of payment.
Very nice. Payment mode. Right. And you might know that, they also save your credit card details, right? Card details. So those things, right? And right. So product ID, product price. right? And many other things. Obviously, if you will start making a list, I'm pretty sure if you will give it half an hour, 1 hour, right, we will have a very long list of variables that we want to capture, right? Let's say, for example, other things can be around seller also, right? Because Amazon is a marketplace, so there are like like a lot of sellers who are coming to Amazon and then selling their product. So, what is the seller ID? What is the seller name? What is the seller registered address? What are the products that seller has under his name, and all of that, right? So, so the first step is always to kind of come up with the list and start capturing this data. Okay, I will create a list of variables. I will pass it on to data engineering team, and I will say that, okay, like these are the variables that I want to start capturing. Right? And then the data engineering team will do their magic and start capturing this information, and we will get a table out of it. Okay. Now, as I said, right, how many variables we have here, over here? I think 10, 13 variables we have just right now. And I'm pretty sure if we will spend more time on this, right? And when we say more time, I'm pretty sure if this is a project that I was doing for a company, they will give me at least a week to kind of come up with the exhaustive list of variables. So I'm sure that we will be able to come up with at least 250, 300 variables. And we will be able to pass it on to the data engineering team. Now, data engineering team has one option that all these 250, 300, whatever the variables list that you have given, they will dump it in a table, and then that table you guys can use. The data analyst or the data scientist guys can use. Okay, this is how the role splits. Data engineering team create the infrastructure where they are capturing all the variables, they are storing that data, and then the data analyst, uh, your data analyst, your data scientist use that data to kind of create meaningful insights out of it. Okay. But if I have one table where there are like 300, 400 variables, and believe me, I've seen tables with even 1,000 variables. Okay. When we have tables like that, it becomes very difficult, right, to find the right information. If let's say there are 1,000 variables in a table, and if I'll ask you that, okay, can you tell me, how much tax we have paid for this particular order, right? It will be very difficult to find that column which talks about the tax for that particular order, like how much GST we have paid, how much we paid to the seller, what was our margin, what was the promotion which was applied, and all of that, right? And that's why once you have collected the data, right, the first step is collecting the data, right? Once we have collected the data, it is very important to organize this data. Okay, so if I have 200, 300 variables, I will not dump it into one single table. Maybe what I will do is I will create different tables out of it. Let's say all of this: name, address, email, phone number, right? I can store it in table 1, and I can call it personal information, PI table we call it, right? Personal info table. This is the personal information of my customer: name, address, email, phone number, right? All of this, their gender, their age, whatever you have captured, that will come under their personal information, right? So that can be my table 1. Similarly, order ID, order value, delivery date, order date, product ID, what was the review of that order, shipping charges, product price, everything can be my table 2. Right? And I can call it maybe order detail table, because it has details related to the order. And maybe we can put this one as table 3. Okay, and we can call it payment details. Now tell me, what is the benefit of organizing my data in this way? Why can't I just dump the data into one table
Security.
and security, you said, right? Yeah. So security, yeah, definitely. The one thing is, the one benefit of organizing it like in this way is easy to find the information. If I know that I'm looking for the gender of the customer, okay, then I know that that information will be present in the personal information. If I'm looking at, I want to find the primary address of the customer. Okay, why primary address? What is primary address? Let's say if you have an Amazon account, you might be ordering on 10 different addresses, right? But there is a default address as well for each customer, like, or let's say a address where you have delivered the most number of orders. We sometimes call it the primary address of the customer, right? If I want to know what is the primary address of the customer, again I will look for personal information table. If I want to see what percentage of my customers use Gmail versus what percentage of my customers use Yahoo versus what percentage of my customers use Hotmail, right? Again, to do that analysis, I will be using personal information table, right? If I want to see that with which bank I should collaborate, right? Like my Amazon sales is coming. Should I collaborate with SBI, HDFC? Should I collaborate with Kotak or IDFC, right? To take that call, I first need to understand that what percentage of my customers are using SBI, what percentage of my customers are using HDFC, what percentage of my customers are using Kotak, and so on, right? And how will I do that analysis? By going to table number 3, that is the payment details table, right? So when we have organized the information in this way, it is easy to kind of figure out where this information will be sitting. So we need not to go through all the variables, right? A long list of variables. Instead of that, we will be able to focus on 10, 15, 20 different variables that, okay, these are the 20 variables which has personal information related to the customer. So that is one benefit. And the second benefit, as he pointed out, right, is the security. So if we have 3 tables, my first table being personal information, my second table being, let's say, order details. Guys, let me know in case my voice is not clear, right? Sometimes either internet issue or the headphone issue, sometimes it is not clear, so just let me know. So personal information, order details, your payment details. Right? These tables at least we talked about. Now, do you think that all this information is equally important, or there are like few like some information which is more sensitive than the other? Which one you feel is the most sensitive information out of these 3?
Payment details.
Payment details, okay, right?
Personal info.
Personal information also, right? So actually, both are important, right? And if I look at from a customer's perspective, at least like we Indians perspective, I feel that the payment detail is the most sensitive one. This is what we feel. But when we look at from a company's perspective, they feel that the personal information is the most sensitive information that we have. Okay. We don't want our customers' details to get leaked out, right? But again, both may be equally important. Okay. So for now, let's just assume that maybe personal information is the most important one, right? So it has, let's say, 5-star security. Okay. Your payment details is having 4-star security. I'll tell you what meaning of this security is. And let's say then your order details one, right? is having 2-star security. What is the meaning of this? The meaning of this is that if I'm joining as a data analyst, product analyst, data scientist, right? If I'm joining as a data guy in Amazon, from the very first day itself, I'm pretty sure that I will be having access to order details table. I need not to raise any access. I'm pretty sure we will be having like the basic access that you get on a day one. In that access itself, you will get access to order details. Okay. So it has some level of security. It means that it is not like that I'm working for Walmart and I can access the data of Amazon. It's not like that. There is some level of security is there. You need to be Amazon employee to access Amazon data, right? But it's not like that. It is a very sensitive information that they don't want it to get leaked. Okay. So order details is important. But if you're working for Amazon as a data analyst, I'm pretty sure you will get that access on the very first day itself. But let's say if I want to work on payment details, as I said, right? If I want to work on the data, this analysis that should I collaborate with SBI, SDFC, or Kotak for the coming sales, right? Then to do that analysis, to take that call, I first need to understand what percentage of my customers use cards from these banks. And to do this analysis, I need to have access to payment details. I'm pretty sure which you will not have by default. Okay. It means that if I want to access payment details table, I need to raise that access. Okay. And when I'm raising that access, my manager need to approve, my manager need to kind of write a summary that, okay, this is what we are trying to do. Okay. For that, this is the information that we will be needing. Okay. And then on top of that, you need to tell them the time frame as well, that we will be needing access to this table for next 2 weeks. And after 2 weeks, again, the access will automatically revoked. Why they are doing all of that? Because it is a sensitive information. They don't want this information to get leaked accidentally. Okay. So if you want access to payment details table, maybe you need to raise access with your manager. And let's say if it is personal information, then even my manager need to take permission from his manager. Okay. So depending upon how much sensitive information is, right, it will have different level of security. And by different level of security, it means that not everyone will have access to it. You need to raise access, and then that access will also be temporary. Okay. And you would have to justify that, okay, why it is important to use this information for doing this analysis. Okay? So that is another benefit of organizing the data. Right? Once you have collected, this is another benefit of organizing it. Okay. And the last part is analyzing the data. Okay. And okay, so if now let's think from Amazon perspective. We were a small company. Suddenly we started getting a lot of orders. We realized that because now we are big, we are growing, we are becoming big, we need to start capturing the data. So we all sat together and we came up with the list of variables. We shared it with the data engineering team. Data engineering team created different tables out of it. What is next? What do you think you will do next after this? Now those tables are ready.
Draw insights from the data.
Very nice. But first, what kind of insights, right? What will be the things that you will be most interested in? Like the
First, we
very
will
first.
check for null values if like they have
Sorry?
any null values in the data. First, we will check about the null values if it had any null values in it.
Right. Yeah, data sanity checks and all of that, let's say we have done.
Data cleaning. Okay.
Right. Let's assume that all of that we have done. Right.
Sales.
Now, from analysis perspective, what is the first thing that you want to do? Like if I will ask you, just for an example, is the very first thing that I want to do is to see, when the customer will order next. Is that the the primary concern that you have, or something else?
We can just look for like the maximum price of an product or the most sold product,
Mm-hmm.
like
Right,
the
right. Very
product
nice.
which
Let's say,
are
for
being
example,
delivered.
yeah,
Hmm.
very nice. Let's say, for example,
Yeah.
you said we can look at which are the products which are selling the most, right?
Yes.
And even more basic than this, how many orders I'm getting every month, right?
Hmm.
Am I getting 1,000 orders, 10,000 order, 1 lakh order? What is the total sales that I have?
Hmm.
What is my average delivery time? What is my cancellation rate? How many new customers I have acquired? How frequently does the customer order? Right? If you look at all of these questions, the question that we just discussed, right? Let's say one question I said that how many orders we are getting. Very basic question, right? What is my total sales? What is my average order value, right? What is my average delivery time, right? What is my how many new customers I acquired last month, right? The customers who had ordered with me first time, right? And like similar things to this, right? Like as you said, which is the most popular product, which is my most popular product, what is my profit and loss, am I making profit or I'm losing money? And about all of these questions, there is one thing common. If you'll notice that all of these questions can be answered with 100% certainty, right? If I will ask you, if you have a access to order details table, and if I will ask you how many orders we got last month, right? Can you answer that question with, like, given that the data is accurate, can you answer that question with 100% certainty?
Yes, we can just sum it up, use the Python function like dot sum of all the individual value, and we
Mm-hmm.
can get the number of orders that has been like shipped.
Right. Right. So it means that if you have access to order details table, I will be able to answer how many orders I got last month with 100% certainty. There is no ambiguity there. If someone will ask me what was my total sales, there will not be any ambiguity there. I know how much I have earned. Like if I'll ask you what was your salary last month, you will know that number, right? You need not to say like at least you know what that number was. There's no ambiguity in that. Similarly, what is my average delivery time? How many new customers I acquired? What is my most popular product, right? What is my profit and loss? Everything you can be answer. You can answer this question with 100% certainty. I don't know the spelling. Huh. With 100% certainty, right? Why we are being able to answer this question with 100% certainty is because these things have already happened, right? So we are being able to answer these things with 100% certainty because these questions focused on past, right? This question focus on what has happened. Right? So whenever someone starts with the analytics, like if there is any company which is just starting with the analytics, the first thing that they do is to answer these questions, like to monitor things. They will create dashboards out around it. The very first thing that the people do is not machine learning, is always reporting and dashboarding, right? Because that creates the most value, right? I want to understand where I'm standing today so that I can, what is the benefit of that? What is the benefit of understanding the past?
It can show us
We
the
can find a
pattern,
trend or anything.
Right.
Predict the future.
patterns with it.
Very nice,
We
right?
we can better plan for future.
Very nice, right? So we cannot directly plan for future if you don't know the past. Okay, so this part where this part of analytics where we try to understand that what has happened, right, is called descriptive analytics. Okay, this part is called descriptive analytics. Okay, so any methods, any technique which revolves around the past data or try to answer the questions which are related to past data is called descriptive analytics, right? Your dashboards, your reports, everything falls under descriptive analytics, right? Describing what has already happened. This is the first step that the people do. The second step is, right, as you have already guessed, answering questions like, what will be my total sales? Right? What will be my total sales? Second thing, how many some X products, right, I will be needing. I will need in the inventory, right? Third, let's say maybe how much money I need, right? You need to invest some money before you will start getting the like the sales, right? How much money I need, how many other resources I need, like for example, how many delivery boys I should have, how many developers I should have, how many analytics guys I should have, like everything you need to plan, right? But if you look at all of these questions talk about the future. Okay, that what will happen in the future. Okay, so when we talk about what will happen in the future, okay, that is in general part of predictive analytics. That is part of predictive analytics. Right now, let's say you are you are working for a hospital, right? And what you are saying is, let's say there are different weeks. Week one, I got 100 customers, 100 patients. Week two, I got 150 patients. Week 3, I got maybe 250 patients. Week 4, I got maybe 400 patients. Okay. Any idea how many patients I might get in week 5?
150 more.
Any guess? Any other guess? So
Six-
one is
The median of it.
500.
550. 550.
550 or something else.
250.
600.
600 actually, right? So what I was doing was, I first increased it by 50, then I increased it by 100, then I increased it by 150. So the next increase will be by approximately 200. Okay. So it will be 600. Anyway, that was not the main question, right? So by looking at this data, I expect that maybe, right? Maybe I might get 600 patients in the week 5. Okay, so by looking at the past data, so I analyze the past data. That is a descriptive analytics, like what has happened in the past. Based on that, I predicted for the future that I might get 600 patients in the week 5, right? But now what? Now what? Does your job ends there? Let's say if you're a data analyst, right? Do you want to be the part of the system till only this point, that where you will be analyzing the data and you will be telling that next week 600 patients might come and do whatever you want with this information? No, right? You want to recommend a few things as well, right? As a data analyst, right? This is what, like, most of the people, I feel that this is what they do wrong. Our job is not just to present the numbers. Our job is also to make sense out of it. That is the one thing. And second thing is, right, do our recommendations as well, that what should we do based on this. So now it looks like to me, as the weeks are progressing, there are more and more patients who are coming to my hospital. And that means that maybe there is a disease outbreak which has happened, and maybe I will get 600 more patients next week. So what will you recommend based on this? Very nice, Aman, right? So the next thing is, let's say if I'm expecting a lot of patients next week, I need to make sure that I have enough number of beds, I have enough number of medicines. And again, even in medicine, which kind of medicine, right? If most of the patients are having fever, right, then maybe I need to have a stock of paracetamol, right? If most of the people are having breathing related problems, I should have a stock of oxygen, right? So what kind of medicines I will be needing? And then a very nice point also, Aman, that we also need to make sure that whether we have enough doctor and nurses, the support staff, to take care of these patients or not, right? So what are these things, right? How many beds? So I'm expecting 600 patients. I will not just stop there. I will say that, okay, because I'm getting 600 patients, out of these 600 patients, obviously not everyone will get admitted. I am expecting 10% of the patients to get admitted, which is like 60 patients. So it means that we need to have at least 60 beds. We need to have at least this much medicine. We need to have at least this much staff, doctors, right? So those recommendations that you do based on your prediction, okay? Let's say I will write it down. Okay. How many doctors we will need? Second, how many beds, right? which medicines, right? And maybe I need to inform a few authorities as well. Like this is the hospitals are also bounded to do. If they see an increase in a particular disease, they are expected to report it to the like whatever their headquarter is, let's say, right? That we are seeing outbreak of this particular disease in our area, right? So all of these things, right, where we are recommending things, okay, is part of prescriptive analytics, prescribing something, okay? All of this is part of prescriptive analytics. Okay, so mainly there are three types of analytics. One is descriptive, one is predictive, and other one is prescriptive analytics. Okay, so for example, another example of prescriptive analytics will be, let's say I'm trying to predict if I'm moving from point A, if I'm moving from point A to point B, if I will take this path, it will take me 30 minutes, which I believe is, let's say, comparatively slow. So I'm expecting 30 minutes if I will be moving from A, like if I will be taking this path, I will be, it will take me 30 minutes to move from A to B, right? But which is the quickest way of moving from A to B, right? That will be prescribing, like prescribing the alternate route that, okay, if instead, like you want to move from A to B and this is the path that you're planning to take, but if you will take, right? But if you will take this path, it might take only 20 minutes, right? So my prescription is to take this path. So I predicted that the path that you are taking is going to take 30 minutes. Then I prescribed that because it is taking 30 minutes, maybe you can take the other path and it might take only 20 minutes. That is also part of prescriptive. You're suggesting something based on your prediction. Okay, so three types of analytics: descriptive, what has already happened; predictive, what will happen; and prescriptive, what can we do of that? What can we do of that information? Okay, now the next thing is there is another type of analytics, right? Descriptive, predictive, prescriptive, we have already talked about. So these are three main types. Okay, so if someone asks you what are different kind of analytics that we do descriptive, predictive, and prescriptive analytics. Okay, there is something called inferential analytics as well. Okay, let me write it down. There is something called inferential analytics. What is inferential analytics? Inferential analytics is when you try to make inferences out of data. The whole picture is not complete, right? The data is not complete, but you try to make your own guesses that this is what might be happening. Okay. In inferential analytics, there are mainly two cases which are covered. One is when you have incomplete data, that is the complete data is not available. See, when the complete data is not available, what you try to do is you try to make inferences from whatever is available, right? You try to make your own guess, right? Inference is nothing but like my understanding is that this is what might be happening. So you try to do that when the complete data is not available, or second thing is we want to comment on the future. we want to predict future, which you might say that now this is predictive analytics. Why we are calling it inferential? So to be frank, these three are the ones where there is no overlap: descriptive, predictive, and prescriptive. Inferential analytics is just another type of analytics, right? And predictive analytics is also falls under inferential, right? So this is predictive analytics only, but it falls under inferential analytics, right? So whenever we do not have the complete picture, the reason can be anything. The reason can be not availability of the data. The reason can be the data cannot be available because we are talking about the future, right? But all those cases are part of inferential analytics. For example, if someone will ask me that, uh, how many trees are there in India? Okay. How many trees are there in India? Now, if I want to guess that, right? Why I'm saying guessing? Because I'm pretty sure that I'm not going to go to each and every tree and market. That is not possible. It will be very expensive and it will be very time consuming. Maybe I will start from Kashmir. By the time I will reach Kanyakumari, there will already be like lakhs of other trees which will be grown in the other parts, right? So it is not possible. So what we will do in that case, maybe what we will do is we'll take a sample of an area and we will see that, okay, in this kind of biome, right? There's something called biome. I forgot how it used to spell. Maybe BIOME, right? Biome is like uh, a, a particular area which has the same kind of environment or diversity in terms of plants and trees and all, right? So what I will do is I will see that, okay, in a particular biome, how many trees are there? Let's say in 1 kilometer square, I will go and I will count the trees, and then I will extrapolate that number for all the other similar biomes. Okay, we will extrapolate that number for all the similar biomes. Right? So what we are doing is, because it is not possible to count each and every tree, we are trying to make a guess. That is part of inferential analytics. Someone will ask me that, okay, what is the average salary of a person in India? Right? We can make a guess by, let's say, taking a sample. We can take a sample which is representative of population. Like we are, taking few people from south, few people from north, few people from villages, few people from, cities, few male, few female, from different age groups, from different background. So I will take like that kind of a sample which is representative of population, and then I will calculate the average of it, and I will say that, okay, most probably, like, this is what the average income in India, right? Instead of going to each and every person, okay, and then calculating the average. So inferential analytics is when the complete data is not available, because sometimes it is very hard to get or it is very expensive to get. Okay, any questions so far?
No, Puneet.
Puneet, I'm not clear on inferential analytics. Means if we means it is like the data, like half data we are getting, and based on that we are predicting, or incomplete data, like.
So yeah, you are right that it is an incomplete data, right? But the reason why it is incomplete, there can be multiple reasons behind that, right? As I said, sometimes it is very difficult to get that data because it is very expensive to do, right? For
Okay.
example, calculating the average salary in India, Why we are not doing it every year? Why we are not doing it every month? Right? Because it's very time consuming and it's very expensive to do. You need to hire a lot of people who will go door to door, right? Counting how many, like how much you are earning, and then there will be people who will be lying about it as well, right? Let's say if I have a lot of black money, I will not tell people that okay, I am earning, let's say, in lakhs, right? So there can be different reason because of which the data is not available, right? But if the data is not available and then you are trying to make a guess, then that kind of analytics is called inferential analytics. Right? So what is the analytics in that? The analytics is like trying to make your guess as accurate as possible. That part is the analytics part, right? For example, as I said that if I want to find out what is the average salary in India, right? And because I cannot go to each and every person, what I need to do is I need to take a sample which is representative of the population, right? Anyone who will not know different kind of sampling techniques might end up taking a wrong kind of sample and might end up either overstating or understating the average, right? As a, for example, if I'll just take a random sample from Bangalore, take an average of that, and I will say that, okay, this is what the average salary in India, that will be wrong, right? If I'll go to my village and I'll just like randomly ask 5-10 people and take that average, will that be the average of India? No. Right? So what I need to do is I need to kind of take a sample which is representative of the population. And when we say representative of the population, what do we mean by that? How can we make sure that all of that is nothing but analytics? Right? And that will fall under inferential analytics.
Out of the total population, we'll just pick up the sample and we'll analyze the data. Like we'll predict forecast out of.
Right. Yes.
Okay.
And where can we get these data? I mean, what will be the reliable source with the authentic data?
So either like either you will have the data with you, right? Or you need to collect the data, right? Obviously, if I'm a private company, if I like if I cannot do it myself, there are a lot of government bodies which maintain this kind of a data, right? So we will try to get it from them.
Okay, okay.
Okay? Let's say, for example, how many babies were born in India? What is the out of those babies, how many survive? If they don't survive, what's the reason behind that? How many deliveries happen in India which are in hospital versus in a nursing home versus at home? All of these data in general is available with the government, because if you are having a delivery, you need to go and you need to get registered with the government, right? So the government is not collecting the data, the people are actually coming to them and registering themselves. Okay, and you need to also write it down, like in that birth certificate, like when entering the details, you need to write down all the details, right? So in general, the government has a lot of data. So if someone wants to do any analysis based on this, that okay, let's say I'm a private company, a very big pharma player or healthcare player, and I want to see that what is the market in India in terms of like I want to open a hospital, like let's say for example Cloud9, which is specialized in, let's say, baby deliveries, right? So how big is that market in India? To do that, I first need to analyze that how many people prefer to get their deliveries done in hospital versus in nursing home versus at home. If most of the people are having their babies delivered in a nursing home or at a home, then the market, although the population is very big, but the market is not that big to invest a lot of money in a very big, high fancy hospital, let's say, related to only pregnancies and deliveries. Right? But how will I get that data? Most probably the government will already have it. Right? If I will not have it, I can actually hire people who have expertise in collecting the data. Right? And how will they do that? They will again go door to door, clinic to clinic, right? Offices to offices to collect that data.
And the way or the parameter through which we can get the data from the inferential analytics, how can we do that? I mean, do we have to, if we have a sample of data, how can we actually analyze that this section of data gives me the baby is delivered in this amount of time or this particular date? So will it be a mean or mode or median or some other statistic parameter?
Right. So we will discuss that where to use mean, where to use mode, where to use median, right? Yes, but all of these are different tools, right? And we try to take like in at least in inferential analytics where you cannot be sure of what the right answer is. You try to be as close to the right answer as possible, right? And yes, what needs to be done and which techniques needs to be done, use is something that we will be discussing in this course.
Okay.
Like how accurate is the prediction and forecast, done using inferential analytics?
Depends upon like this is I'm talking about in general in machine learning and stats. So see,
Mhm.
what happens is that a lot many times the people try to uh, uh, you know see whether your model is accurate or not, or your analysis is accurate or not based on the accuracy, right? Which I feel is a very wrong metric to judge. Reason being is, if I will ask my machine learning model, okay, just 1 minute, sorry. Yeah. If I will ask my machine learning model to differentiate between, like, I have a few photos of ant, I have a few photos of elephant, right? I want my machine learning, like, so I have, let's say, 10,000 photos, a mix of photos of ants and elephant. And I want my machine learning algorithm to differentiate between the two photos, right? I want my machine learning algorithm to tag that this is an ant, this is a elephant, right? And that model accuracy is, the model accuracy is 90%. 90% of the time, my model is accurately being able to identify what is an ant, what is elephant. Will you consider it a good model or a bad model?
It's a bad model only, right?
Bad model,
ide-
yeah.
because identifying
90%
ants
is
and
nothing.
elephants,
It should be like 100 or 99 at least.
at least above 95%.
Just 1 minute, guys. Just 1 minute, sorry. No, actually, you are right. So you said that at least it should be 95. I believe that it should be 100, to be frank, right? In general, the machine learning models are supposed to be better than humans, right? And even not better than humans, at least at par with the humans. Okay. I can, with 100% accuracy, I can differentiate between an ant and an elephant. Okay. So a model should also be able to do the same. So even 95%, I will consider it as a bad accuracy. Okay. But now, if I will ask you something else, if I will ask you, um, my pen is not working. Yeah. So let's say if I will ask you to predict if like the stock market will go up or it will go down, and I am being able to predict that with 65% accuracy. So 65% I'm accurate whether the market will go up or the market will go down. Now tell me if it is a good model or a bad model.
Good model.
Yeah, it's a good model, close to good model.
Right. It is
I
actually
would,
close to good model. And actually, to be very frank, it is a very, very good model. Okay. When it comes to stock market, if you are being able to create a model which is 65% accurate, this is a very, very good model. Okay. So when you ask me that question that how much accurately we will be able to predict using inferential analytics and all, right? To be very frank, the answer is it depends upon the problem statement. Okay. A few problem statements are easy to solve, and there even 90% accuracy will be considered bad. and a few problems are very difficult to solve, and there even 65% will be considered very good. So I cannot give a number that, okay, if it is above 80%, it is good, or it is below 80%, then it is bad. Right? It's totally depends upon problem statement to problem statement. Okay.
Yeah, thank you. Got it.
Any other question before we move forward? So now what we'll try to do is, just give me 1 minute. I will open my Excel. We will try to now discuss, because we are anyway on the topic of sampling. Let's discuss what are the different type of samplings that we have and where to use which one. Just 1 minute. Okay. Yeah. So we have mainly four, like there are many types of sampling technique, first of all, but we have mainly four types of sampling techniques. Okay. One is simple random sampling. Another one is systematic sampling. Another one is a stratified sampling, and the clustered sampling. Okay. Let's try to understand each of it one by one. Simple random sampling, as the name suggests, right? It is simple and it is random. Okay. It means that what I need to do is, I just need to randomly select a few people. Okay. There's nothing complex about it. Just randomly. Let's say if you're seeing 100 people, you want to select 10 out of it. Just simply say, okay, you. That's it. Right. There should not be any logic behind it. That's one simple random sampling is, which we do most of the time. Okay. Another one is systematic sampling. In systematic sampling, what happens is that we try to take a sample after an equal interval. Okay. Now let's say, for example, every like you will skip these two guys, then you will take it, then you skip these two guys, then you will select him, you will skip these two guys, and then you will select him. So if you look at it, what is happening? I'm taking a sample of, let's say, every like after every third person. I'm skipping two and I'm taking the sample from the third person. Right? When the sampling is important, when let's say when the things are changing. Like for example, I want to check for a mall whether the customers are satisfied with the parking or not, right? Whether they were easily be able to get the parking or not. This is what I wanted to check. Like I want to check for a particular mall, like how much satisfied the customers are with the parking facility. Now, tell me, like if on a Monday morning, in a particular mall, if I will check, like if I'll ask customer, did you have problem in finding the parking spot? How was your experience and everything? Most likely, I'm pretty sure that their answer will be positive, that it was quite empty. They were easily able to find a parking spot, right? But the same thing if I will do on a Friday evening, then the customers might have a different point of view, that okay, it was very difficult to find a parking spot. They had to wait for 15-20 minutes, right, to get the parking and all of that. Okay? So it means that here what is happening, the things are changing over the period of time. At peak hours, I'm seeing that the experience is changing. Customers might have a different experience on a Friday evening as compared to the customers on the Monday morning, right? So what I can do is I can collect the data for 1 week, right? And what I can do is that every, let's say, 10th person who will be coming into my mall, every 10th person, right, irrespective of what time of the day or what day of the week he is coming, every 10th person I will be stopping and I will be asking him, how was your experience with the parking? Okay. And based on that, I will take a final call that whether the experience was good or the experience was bad. Okay. Why I'm doing it in this way? Because I know that the experience is going to change a lot depending upon which time of the day it is and which day of the week it is. Okay. That's how your experience might change. Another example of systematic sampling can be, let's say, you know, when I was in school, we used to play basketball. Okay. So hypothetically, let's say we have 14 players. Player 1, player 2, player 3, like in this way, we had 14 players. Okay. Now, what our coach used to do that, every morning he will just divide us into two teams. Let's say call it team A, and the other one is team B. So in the morning, the coach will divide it into team A, team B, and he will just randomly select. Let's say, for example, you are in A, you are in A, you are in A, you are in A, and let's say maybe because I need to get 7 people, like, and then whosoever is remaining will be part of team B, 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 B. So he will just randomly assign people to team A and team B. Example of random sampling. But then what the problem is? The problem is that if the team A will win, the team B will say that, sir, you were very partial. All the good players were in team A only. And that's why we lost. Right? And if team B will win, the team A will say that, sir, you were being very partial. It was not our fault. All the good players were in the team B only. Right? So we will never accept our mistake. We will always say it is just the coach is being very partial. All the good players are in the next team, and that's why they won. Right? So to avoid this kind of a thing, right, our coach started that now onwards what will happen. Okay, now onwards what will happen, you guys need to stand in a line. Okay, and in the increasing order of your height. It means that, let's say, 2 might come here, 5 might come here, right, 8 and 9 might come here, 4 come here. So what we are doing is we are putting people in increasing order of their height. I'm pretty sure similar things you guys might have done at some point of your life. Right? So what we will do is we will sort the people based on their height. Right? And now when I need to assign teams, I will say that, okay, the first person will be in team A, the second person will be in the, the second person will be in the team B. third person will be in the team A, fourth person will be in the team B, right? And so on. Right? In this way, right? Because in basketball, in general, people consider that the taller you are, the better you are, right? So I will sort the people based, the players based on their height, and I will just divide them into A, B, A, B, A, B, A, B. And this is nothing but systematic sampling. Okay. So, or let's say another example can be maybe, when I was in school, we need to do these projects, right? That, the teacher will ask us to create a group of four and then, uh, make a science project. And what will happen always, right? The people, the students who are in, like the friends together, they will make one group, right? But what teacher wants is that there should be a mix of group, right? A few people are good in sport, few students are good in academics, right? So we want a mix of students. So what they will do is they will sort the students maybe based on their marks, the marks that they have obtained in the last exam. So I'm sorting the students based on the marks, right? And I will say that, okay, you are in the project one. This person is in the project 4, 2, 3, 4, and 5. Then same thing I will repeat, right? So what I'm doing is, again, this is also an example of systematic sampling. I'm creating groups after sorting the students based on the marks that they obtained in the last class test. Okay, so that I'm creating a mix of, I'm creating a mixed group. Right? So here also we are doing systematic sampling after a equal interval. Right? So this is an example of systematic sampling when you take sample after an equal interval. Another example is stratified. Another kind of sampling is stratified sampling. In stratified sampling, first of all, the word stratified is coming from the word strata. Okay, there is something called strata. Strata. Okay, there is something called strata. Strata means group. Okay, strata means group. So stratified sampling, you can always take it as a group sampling. Okay, what is the meaning of group sampling here? So in stratified sampling, we will first be creating the groups. Okay, and then we will be taking the sample. Okay, so the grouping can be based on anything which you feel is relevant, and I will talk about what we mean by relevant here. Okay, but let's say all of these are of the same color. It means that they belong to the same category. So this is one group. This is second group. This is third group. So I'm first creating the groups. Okay, that's why it is called group sampling or stratified sampling. I will first take creating the groups, and then I will be taking proportionate samples from each group. Okay, what is the meaning of proportionate samples? Proportionate sample means the bigger the group is, more the number of samples will be coming from that particular group, right? Let's say this is group 1, this is 2, and this is 3. So I can say I can see that the group 2 is twice as big as group 1 and group 3. Okay, so it means that from group 2 there will be twice the number of samples which will be coming as compared to group 1 and group 3. And that's why from group 1, if there is one sample I'm taking, from group 3, if I'm one sample I'm taking, from group 2 I'm taking 2 samples, because group 2 is twice as big as group 1 and group 3. Okay. So again, I will repeat, stratified sampling is nothing but group sampling. Why? Because strata means group. So stratified sampling is equivalent to group sampling. Why we are calling it group sampling? Because first we create the groups and then we take proportionate samples from each group. What is proportionate sample means? If you if you're a bigger group, there will be more number of samples which will be coming from them, coming from you. If you are a smaller group, then there will be lesser number of samples which will be coming from your group. Okay, and how this sampling will be done? How this 2 and 8 were selected? It is a random sample. Okay, so within a group, from within a group, I will take random samples. Random samples. No logic behind that. Creating sorry, I think I lost you guys. Right. So for how many for like was it for few seconds or few minutes? Like
Few seconds.
okay, cool. Okay, let me check the connection once. Let me know if my voice is not clear or it is breaking or anything. Okay, I'll try to connect to a different connection. So I was saying that it is stratified sampling, which means it's a group sampling. Group is something that you will logically create. Okay, there should be some logic behind creating the group. And we will discuss again by examples that what should be that logic. And once the groups are created, we need to make sure that we are taking proportionate samples out of it. Proportionate sample means bigger the group, more the number of people who will be coming from that particular group. Now, the fourth kind of sampling is clustered sampling. Okay. Now, cluster is also a group, strata is also a group. So, what is the difference between clustered sampling and stratified sampling? Okay. A stratified sampling, the group is something that we create on our own understanding, right? We are creating the groups ourselves. That we will be saying that, okay, these 10 people is part of one group. These 20 people are part of another group. These 30 people are part of group 3, right? But in clustered sampling, the clusters exist naturally. Okay. Most of the time, you are not making those clusters yourself. Those clusters exist naturally. Okay. Again, I will take an examples later to explain it better. But in cluster sampling, you will see that I am not creating the group myself. In stratified sampling, yes, I was creating the group. In clustered sampling, the group will exist naturally. That is one difference. Okay. In stratified sampling, I'm creating the group. Clustered sampling, the groups exist naturally. The second difference is in stratified sampling, we are trying to create a homogeneous group. What is the meaning of homogeneous group?
Same type.
Similar kind.
Exactly, right? Same type. So we are making sure that the same type of individuals are clubbed together. They are part of the same group. Why? On the other hand, if I'll talk about cluster sampling, right? We are making sure that we are creating a heterogeneous group or a diversified group. Okay. So if you look at the stratified sampling groups, like the first group, second group, third group, in one group, the people were similar, the same color. The same color represents here, they are similar to each other. While on the other hand, if you look at the, If you look at the clustered sampling, each cluster that I have, this is each cluster. If you look here, the people need not to be the same in each cluster. They can be different from each other. Actually, we prefer that, right? We prefer that the people should be different from each other in each cluster. So that is the second difference. First difference was in stratified sampling, the groups will be selected by us. In clustered sampling, this cluster is something which is naturally existing. That is the first difference. Second difference is that in case of stratified sampling, the people are within a group are similar to each other. That is a homogeneous group. On the other hand, in case of clustered sampling, each cluster, okay, is heterogeneous, or the people are different from each other. The third main difference is now, in case of stratified sampling, once the groups are decided, we take random proportionate samples from each group. What is proportionate sample? Again, bigger the group, more the number of samples will be coming. And how that sample is taken? Random sample. Okay. And in case of clustered sampling, the whole group will be selected. The whole cluster will be selected. There will not be any sampling within a group. Let's say, for example, here 5 and 6, both were selected. 11 and 12, both were selected. So there is no sampling within a group. Randomly out of all the clusters, I will select a few clusters, and then all the individuals in that cluster will be selected. Okay. Clusters are made, and then randomly I have selected a few clusters. On the other hand, in stratified sampling, once the groups are made, there was a sampling within the group as well. From second group, not everyone is getting selected. From the second group, there is a random sampling that I'm doing. Okay, so that is another difference. Where to use which kind of sampling technique, we will again discuss. Right? Let's see how we can do it. Okay, now let's say I have these how in total I have 1,000 customers. Okay, in total I have 1,000 customers, and I want to take a random sample of 100. 10% people I want to select randomly. Right, a very common thing. Let's say, for example, we used to do in retail, right? Walmart used to send, or let's say, for example, Jepto also does that, right? They will be sending sometimes a few gifts, like, or the vouchers with their order. Let's say maybe a chocolate that they will send, or maybe a brochure they will send, something they will send, right? And they will not send it to everyone. They will randomly select a few people. All right. And so let's say I want to send some gift to randomly selected 100 people, 10% of my customers. So how will you do a random sampling? Like if the people are standing in front of you, it is very easy. I can just say, okay, you, and you, right? You guys are selected. I can do a random sampling like that. But when you are online, right? When you have a data set from which you need to select the people, I cannot simply say, like, I need to select, let's say, 100 people out of it. I will not say, okay, this one, then let's say, just 1 minute. Okay, I will not say that, okay, this one, and then this one, then this one, then this one, then this one. Like, if I'll do it this way, it will be like, it will take a lot of time. And I'm selecting just 100 people. If I want to select 1,000 people, right, then doing it this way will take a lot of time. So I want some automated way. Okay, some automated way of doing it. So what I will do is, I need to select 100 people, right? So what I will do is, first I will randomly generate a number. Okay, we can do it in Python also. I'm just showing you how we do it in Excel. I will randomly generate a number between 1 to 100. So each customer is assigned a number between 1 to 100. Like totally random, no logic behind it. Okay, so this function is just randomly generating a number between 1 to 100. Now what I will do is I will say that if, because I want to select 10% of the data, I will say that, okay, if this number is less than equal to 10, then I'm calling it selected. Selected means that you are part of the sample, and rejected means that this person is not part of the sample. Okay. So randomly it is now rejected, selected, rejected, selected. And let's see how many people we have selected now. Let's filter for selected customers. Okay, how many people are there? 107, right? Which is approximately 10% of the total. Now, if I want to select 100, I can remove randomly 7 people out of it, right? But in general, the rules are not that hard and fast. So if they have asked for 100, I can send this 107 list. But if you want to be exact 100, remove 7 people out of this, right? So in this way, I have just randomly selected just right now 100 people out of this, 10% of the data. No logic behind it. Okay, so I just randomly generated a number, and when the number is less than 10, it is selected, otherwise it is rejected. If I want to select 30% of this sample, then what is the condition that I will write? If I want to select 30% of the data, less than 30. What should we do?
Change the condition to less than 30.
Yes, exactly. Very nice, right? What I will do is I simply will say that, okay, less than 30. And now I will be able to select 30% of the data. Now, if I'll check approximately, I'm pretty sure approximately we will have 300 samples. So how many? 280. Okay. So in this way, you can select 30%, 40%, 20% data, whatever is needed. The same thing you can replicate in Python also. In Python also, you can randomly generate a number. Once the number is generated, you can just simply write a condition that, okay, if the number is less than this, selected, otherwise rejected. Very simple. That is simple random sampling. Okay. Now the next one is stratified sampling. Okay. Let's try to take the example of this as well. Now, let's go through the question first. We work for a small company of 1,000 people. Okay, so there are 1,000 employees in the company, and we want to find out how they are saving for their retirement. Okay, so there are 1,000 employees in our companies, and we want to find out how they are saving for their retirement. Now, if I want to understand how the people will be saving for their retirement, will it depend, like their way of saving, will it depend upon in which department they are working, of which gender they are, or of which age they are? Out of, let's say, these three things, which one do you feel is the most important thing which will be deciding how they are saving for their retirement? Is it their department, is it their age, or is it their gender?
Age.
Will be age, right? If you are a very young person, like if you are in your 20s, maybe you might not have thought about the retirement altogether. Or if you are saving for your retirement, you might be saving it in small cap fund, mid cap fund, right? Might not have invested a lot into FDs, RDs, and all, right? On the other hand, let's say if I'm a person in my 50s, I might not have invested a lot in the stock market. right? I might have most of my money lying in either debt fund or FD or RD, right? So it means that the age is having an important role to play to understand how the people are saving for their retirement, right? And that's why when I will be creating the group, I will be creating the group based on age, right? And this is a very important part of stratified sampling, on which factor you want to create the groups. You can create it on multiple factors also, right? If you feel that no, gender will also be an important thing, then you can create group a combination of this, age and gender combined together. Okay, so you can use multiple variables also, right? But whatever you feel important, only those variables you should use and create simple groups out based on that. Okay, so what I did, because we feel that age is an important criteria, right? So what we have done is we divided the people, the employees based on their age. 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 plus. And for each age group, I have written the total number of employees present in that strata. Strata means in that particular group. So 160 employees here, 220 here, 240 here, 200 here, 180 here, right? So this is the distribution of people in each group. Okay. Now, let's say we have decided that I want to take a sample of 50. So I want to select 50 people out of this. Okay. Now, like because I want to select 50 people out of it, and we know that the proportionate sample should be taken. Proportionate sample means that the bigger the group is, more percentage of people should come from that. So what I will do is I'll first try to understand how much big this group is. Like for example, what percentage of people are coming from this particular group? So 16% are coming from here, 22% are coming from here, 24% are coming from here, 20% are coming from here, 18% are coming from here. Like this percentage shows me the size of the group. This percentage shows me the size of the group. Okay, now I've said we need to take proportionate samples. What is the meaning of that? Proportionate samples means that bigger the group, more number of samples will come, and smaller the group, lesser number of samples will be coming. Okay, so if I need to take 50 people, if I need to take a sample of 50 people, what I will say is of this 50, 16% of this 50 should come from group number 1. Okay, 22% of this 50 should come from group number 2. 24% of this 50 should come from group number 3. 20% of this 50 should come from group number 4, and 18% of this 50 should come from group number 5. Okay, Sumit, is it better now? There was a plane passing by. Is it better now?
Yeah, it's better now.
Right. So there's this aero show happening in Bangalore. So they do a lot of practice and shows, I think, because of that. Okay. But thank you for letting me know, and do let me know if it breaks again. So let's say we have 16% of this 50 will be from group 1, 22% of this 50 will be from group 1, group 2. Similarly, 24% of this 50 will be from. So now I know that what is the percentage, what is the number of people that I need to take from each group. And if you add this up, you will see that it is 50. If I'll add this up, I will get total 50 samples. And how these 8 people will be selected out of this 160? How should I select these 8 people out of this 160?
Randomly.
Randomly. Okay. Similarly, this 11 people will be selected randomly out of this 220 people. These 12 people will be selected randomly out of this 240 people. Okay, so this is how we do stratified sampling. In stratified sampling, the main thing is that we need to make sure that the groups are created based on some logical reasoning. You guys still facing problem? Is the voice not clear?
Yes, clear.
Yes, clear.
Okay, thank you. Yeah, this is how we do stratified sampling. And let's talk about quickly about the cluster sampling also. In cluster sampling, what happens is, let's say, let's first look at the problem statement. We are interested in finding out what is the average math knowledge of 7th grader in your cities, in your city. Okay, in your city, I want to check a 7th class student, what is the level of mathematics that they have, that he has. Okay, are they good in mathematics or they are not so good at mathematics, right? And now I have taken example of Bangalore. In Bangalore, let's say there may be 200 schools. There are definitely more than that, but let's say there are 200 schools. Okay, now if I want to understand what is the level of mathematics, what is the knowledge of mathematics that the 7th graders are having, and if I will random, like let's just assume that I have the list of all the 7th graders in Bangalore. Okay, and let's say I have a list of 1,000 students, and I randomly selected maybe 200 out of it. Okay, so there can be a case that if I have these 200 schools, let's say school 1, right? I have these 200 schools. Right, and there are in these 200 schools, maybe in the 7th class, maybe 10,000, right? 10,000 students are studying.
Sorry, we are talking about cluster sampling, right? No?
Right, yes. Okay, so what we want to do is we want to understand what is the knowledge of math for the 7th grader in our city, that is, let's say in Bangalore. In Bangalore, there are 200 schools, and let's say there are 10,000 different students studying in those schools. And out of those 10,000, I decided to take a sample of 500. Right? Because I cannot talk to each and every student. So I thought that, okay, I randomly selected out of those 10,000, like, let's assume you have a list of all the students. So you randomly selected 500. Now those 500 students can be distributed in any way. Like this, there is a 0 student from school 1. Maybe there are 3 students from school 2. Maybe there is 1 student from school 3. There are 5 students from school 4. There is no student, right? Then there is 3, there is 5, there is 7, there is maybe 2, there is maybe 1. Right? This kind of a thing will be there. Right? And out of these 200 schools, I might end up going to 170, 180 schools. Right? So even if there is 1 student that I have randomly selected from school 3, I need to go to school 3. You agree? Let's say if there are 10,000 students who are studying in the 7th class, I randomly selected 500. Now these 500 students can be anyhow distributed in these 200 schools. Right? And if I want to understand their knowledge of math, I need to visit the school. That means that there will be a few schools where even if there is a 1 student, I'm going there. And given the traffic of Bangalore, right, it's going to take me a lot of time to cover these 180, 170 schools. You guys agree on that?
Yes.
Yeah.
Right? So what will be better in this case? In this case, I think it will be better that if I'm in a particular area, right? Let's say in Bangalore, we have area like Whitefield. Okay, if I'm in the Whitefield area, if I've come to Whitefield area anyway, then whatever the 2, 3 schools which are there in the Whitefield area, I can cover all of those. That will take lesser time than going from Whitefield to Kormangla, Kormangla to Banashankari, Banashankari to Whitefield, like going it like that. Instead of that, if I'm in a particular area, I would like if I'm going to a school, I would rather talk to all of those students who are studying in the 7th class rather than going to multiple schools and from each school talking to only 5 student, 2 student, 1 student like that. Okay, so clustered sampling, what it says is, right, that select the areas. Okay, maybe these 200 schools, if I will divide them by area, there are 20 different areas in Bangalore. And again, it will not be as simple as this, but let's say there are 20 areas and in each area there is approximately 10 schools. Now, in each area, not all the school will be of the same kind. Some school will be high-end schools. Some will be of mid-level and some will be of low level. Low level, I mean like from studies perspective. Okay, so there are some schools which are very popular because the studies is very good. There are some schools which are not so popular because maybe the teachers are not that great. Right? But if I'm going to a particular area, here cluster is nothing but but schools in a particular area, right? As I was telling you, in case of stratified sampling, we create the group. In case of cluster sampling, the groups naturally exist. So if I'm going in Whitefield, then all the schools of Whitefield will fall under cluster 1. So I have not put them into same cluster. They are by default in the same cluster because all of those schools are in the same area. Okay. So I have created multiple clusters. In each cluster, there will be multiple schools. Some schools will be of high end, some mid level, some low level. And then I will randomly select a few areas, right? Cluster 5 is nothing but an area. Let's say, for example, Kormangla. Cluster 10 is nothing but an area. Let's say Whitefield. Cluster 14 is nothing but an area. Let's say Indranagar. Right? So if I'm going to Whitefield, I will cover all the schools in Whitefield. If I'm going to Kormangla, I will cover all the schools of Kormangla. If I'm going to Indranagar, I will cover all the schools of Indranagar. Okay, so here if you look at it, the cluster exists by default because whatever the schools that are present in one particular area, that will fall under same cluster. Second thing is that once a cluster got selected, let's say once I have randomly selected that I will be going to Indranagar, Kormangla and Whitefield, right? So once I have randomly selected, I will be going to all the schools of that particular area, right? Which I was telling you in cluster sampling as well, that in cluster sampling, once a cluster is selected, then all the individuals in that particular clusters will be part of the sample.
But this won't be homogeneous, right? Like
No, this will not be
it will be
homogeneous.
homogeneous.
No, it will not be homogeneous, right?
I mean, when we go to cluster 1, so
Right.
all the students will be homogeneous only, right?
No. In cluster 1, there are different kind of schools, right?
Okay, okay,
In each cluster, there are different kind of schools.
okay, got it.
Okay. Yeah, this can happen that yes, from one school, there will be same kind of students.
So from one school, like how many students will be selected? Like what's the
Everyone.
criteria?
Everyone. Yeah.
And does it, I mean, is it mandatory to have a combination of high-end, middle level, and low-level schools in that cluster?
No, it's not mandatory. It just in general happens that way, right? Let's say, for example, we look at this example also. In a few cluster, if you look at it, like let's for example, this cluster, these two were exactly the same, right? So a cluster can be homogeneous.
Okay, okay.
Okay, the cluster can be homogeneous, but we are not forcing it to be homogeneous. Unlike in stratified sampling, where we are forcing similar people together in one group. Okay, in cluster sampling, whatever is naturally happening, we will let it happen.
Okay, got it. Thanks.
Okay. Yeah. Okay, any other question, anyone?
Like if we select only 3 clusters out of available clusters,
Mhm.
the precision will drop down, right?
Very nice, right? Very nice point actually. So actually, a stratified sampling is done in this way. Like why we have not taken a random sample here, right? Because we wanted to be more accurate. We wanted like each group to have the right representation and all of that, right? So stratified sampling is in general actually better than random sampling. Okay, if you had taken the random sampling, you might end up having the same proportion also. That could have happened, but I'm still forcing it in such a way that I'm getting the exact proportion. So stratified sampling is better than random sampling when it comes to accuracy. Okay. On the other hand, cluster sampling is more time saving and money saving sampling technique. It is not the more accurate one. Okay. So cluster sampling is not done in this way because it is more accurate. No, it is done in this way because it helps you in saving time and money. Okay. So yes, you are right. It will be lesser accurate as compared to stratified and random sampling.
And in stratified sampling, we'll have to put more efforts to collect the data.
Right. Yes. Okay. Any other question, anyone? Cool. Then let's do one thing. Okay. We will try to, like I have a few sampling methods, like the scenarios, and you should tell me that which kind of sampling method it is according to you. Okay. Let's go one by one. The first one. A pollster, a political pollster, right, wants to survey a representative sample of voters in a particular state. They use random number generators to select phone numbers from a list of registered voters and then call those voters to ask about their voting preferences. What kind of sampling is this?
Random sampling.
Random sampling.
Random sampling.
All right, this is a random sampling. Okay. Similarly, the second one, a researcher wants to survey customers at a busy shopping mall. They stand at the entrance of the mall and select every 10th person who walks in to participate in the survey.
Systematic.
Systematic.
Systematic sampling.
Very nice. Systematic sampling. Now, a public health official wants to survey household in a particular neighborhood about their health habits. They randomly select a few blocks within the neighborhood and then survey every household within those blocks.
Clusters.
Clustered sampling.
Cluster.
Clustered
Cluster.
sampling.
This is a cluster sampling. Okay. Because see, these blocks are nothing but clusters, right? These blocks I have not created using some logic. Like I have not created these groups. These groups exist by default, right? It's not like that I have forced people that, okay, you guys will be living together in block A, you guys living together in block B and all. I have not done that. In stratified sampling, you create the groups. Always remember that. Okay. In cluster sampling, the groups are already existing. Okay. So because here the people are living in blocks, like on their own will, it's not something that we have decided. This will be called cluster sampling. An airline wants to survey passenger about their in-flight experience. They divide the passenger into different groups based on their sitting class, economy, business, first class, and then randomly select a sample of passengers from each group to participate in the survey.
Stratified.
Stratified.
Right? Stratified. So here, if you look at it, like I could have divided people based on, let's say, their age as well. But will it make sense? Like the experience of the flight might not change drastically with the age. It might not change drastically with the gender, but it will change definitely drastically with whether it is an economy, business, or first class student. Oh, sorry, customers. Okay, so it is a systematic sampling. My bad. Stratified sampling. It is a stratified sampling. Okay, now this one. A sports fan wants to survey fans at a baseball game. They walk through the stand and select every fifth row to ask fans about their opinion on the game, whether the game was good or not.
Systematic
Right?
sampling.
Systematic sampling. A researcher wants to survey employees at a large corporation about their job satisfaction. They divide the employees into different departments and then randomly select sample employees from each department to participate in the survey.
Stratified.
Stratified.
Right? Stratified. Here I'm doing it like we divided the employees based on department because maybe the researcher thought that your satisfaction level can change drastically with which department you are working for. Right? It happens. In the same companies, a few employees are happy and a few employees are not happy. So for example, maybe the sales guys might not be that happy as compared to someone who's in talent acquisition, right? Just randomly saying. Okay, more the pressure that you will have, right? Maybe you're satisfied. You will not be that satisfied with the job. So it is stratified sampling. A researcher wants to survey small business in a particular area. They randomly select a few zip codes within the city and then survey all the business within those zip codes.
Cluster.
Clustered sampling. Very nice, right? Again, a zip code is something which is not something that I am deciding that, okay, these people will live in this particular zip code, right? It is naturally occurring. So this will be clustered sampling. Okay, yeah, that's all on this. Right. So we discussed what are different kind of sampling techniques are there. Sampling techniques are used so that like if you will take a sample first and then you will make an inference about the population. That okay, if the sample is like this, then most probably, right, the population will be like this. Okay. Now, let's move on to the next part. Okay. Next part is a scale of measurement. That is the different kind of variables that we have. One kind of variable is ratio variables, right? This ratio variables, nominal variables, interval variables, and ordinal variables. So let's try to understand them one by one. Okay. Let's try to understand
Can
them one by one.
we take a 5 minutes break, if you don't mind?
So I was thinking that we'll continue for another 10-15 minutes, and then maybe we'll wrap up the class. Okay. We need not to continue till 12. Okay. Is that fine with everyone?
Yeah.
Yes, fine with me. Can you show me the slide again? Which
Which
topic
slide?
are you reading? Before this, just
Before
before this.
this one?
Scale of measurement. Scale
No,
of
no.
measurement.
Okay, scale of measurement. That one. Okay. Yeah.
Okay.
I'll just put it here.
Sir, will you put these slides in the Google Drive for us to refer?
Right. Yes, definitely.
That
Okay.
Excel sheet as well, please.
Yeah. Anything that we will be discussing in the class, I will put it in the shared drive. If in case I don't, please do remind me. I'll do that. Most probably it will be a miss if I will not.
Yeah,
Okay.
thank you.
So, what are different kind of variables we have? We have mainly two types. Okay, categorical variables. Okay, and the another one is continuous variables. Okay, so categorical variables we have, continuous variables we have. Categorical variables are also called qualitative variables. Uh, okay, why they are called qualitative variables? Because it tells the quality of the things. For example, the color of the car. Okay, color of the car is a qualitative variable or a categorical variable because it tells me the quality of that particular thing. A car is green in color, a car is red in color. It's the quality of that particular thing. Okay, someone is male or female, that is again comes in the quality. Okay, so categorical variables are also called qualitative variable because it tells us the quality of something. Continuous variables, on the other hand, is called quantitative variable. Okay, qualitative variables and quantitative variables. Variables, quality of something. Quantitative variables means quantity of something, like how much, right? Like for example, weight of someone, height of someone will fall under continuous variables or quantitative variables. Categorical variables then can further be divided into two parts. One is nominal and other one is ordinal. Okay, what are nominal variables? Nominal variables which does not have any order in it. For example, maybe gender. Gender is a qualitative variable. At the same time, it does not have any order in it. You cannot say male is better than female or female is better than male. Okay, there is no order in it. Similarly, name of someone. Name is also a categorical variable. At the same time, no name is better than the other. There is no natural order in it. Okay, color. Like red, green, blue, there is no order in it. On the other hand, ordinal variables by default has some order in it. For example, rank. If you are running a race, right, someone will come first, someone will come second, someone will come third, right? But we know that the guy who came first was definitely better than the guy who came second, and definitely the guy who came second was better than the guy who came third. So there is a natural order in it. Okay, so rank is one of that. Category, income category, for example, high, medium, low. Right? high, medium, low. It is also a categorical variable. On categorical variables, you cannot do any mathematical operation. Okay. So, for example, just for example's sake, I cannot say that third position minus second position will give me first position. Right? It does not make any sense. I cannot do this mathematical operation that third position minus second position will give me first position. Okay, or third position plus plus second position will give me fifth position. Those kind of operations does not make any sense, and that's why it is a categorical variable. If you can do mathematical operations on something, then that will be a continuous variable. Okay, so another way of identifying categorical versus continuous variable is just ask yourself, can I do addition, subtraction, multiplication, division on these variables or not? Income category. I cannot say high income minus medium income will give me low income, or 2 times low income is same as medium income. No. Or medium income divided by high income will give me, like, all those operations will not make any sense. Okay. So we have categorical variable, continuous variable. In categorical, again, 2 types, nominal and ordinal. Nominal, there is no order. Ordinal means there is an order. Okay. Nominals means no order, or ordinals means already there is an order. Then in continuous variables also we have 2 types. We call it interval variable and we call it ratio variables. Okay. What is the difference between interval variable and ratio variable? In ratio variable, true zero is defined. Okay. And in interval variable, true zero is not defined. Okay, what is the meaning of that? Let's take an example of temperature. Okay. In temperature, we have 0 degrees Celsius. What is the meaning of 0 degrees Celsius? What is 0 degrees Celsius?
Cold.
It is cold, you said. Yeah, it is cold.
Yes.
You are right. Right. But okay, let me ask you this. If something has a 0 weight, what is the meaning of that?
Origin. It's like the origin point. We
Right.
can say
So
that.
zero zero weight means that thing does not exist. You agree? Right? If there is no weight into something, then that thing does not exist.
Yes.
Right? When I say 0 degrees Celsius, what temperature is a measurement of what? What do we measure using temperature?
How hot
The
it is, how cold it is.
Right.
yeah.
Exactly. Right. The degree of hotness. Is 0 degrees Celsius means that it is the absence of heat?
Yes.
Okay, so let's say 0 degrees Celsius means it is absence of heat. That is, there is no heat present in the system at 0 degrees Celsius. So it means that
And
if there
no
is no
cold.
heat present in the system, I cannot make it any colder. Right? To make something hot, you need to supply heat. To make something cold, you need to remove heat. So if 0 degrees Celsius is absence of heat, I cannot make it any cold, because to make something cold, you need to remove heat. And you are saying that 0 degrees Celsius means there is no heat. You guys understood the question?
Yes.
If temperature is measurement of heat, and if 0 degrees Celsius means absence of heat, and to make anything colder, we need to remove heat. So if you like I can only rob you if you have money, right? If you do not have money, I cannot make you any more poor, right? If poor and rich is defined based on money, right? And if you don't have any money, then I cannot make you any more poor than that, right? The same is when if temperature is measurement of heat, I cannot make it any more colder if there is absence of heat. But the temperature like -2 degrees Celsius, -5, -10, -40, -50 do exist. It means that at 0 degrees Celsius also there is heat present in the system that you are removing, and that's why the thing is becoming more colder. Right? So what is 0 degrees Celsius?
It's
But
just a
0 degrees
number.
Celsius is defined, right? So it comes under ratio, isn't it?
It's like a freezing
Mhm.
point, we can say.
Right. Very nice, right? Actually, 0 degrees Celsius is not absence of heat. It is just a reference point. Like as he said, it is just a reference point. What is this reference to?
The temperature at which water become ice.
Very nice, right? It's a freezing point of water, right? It's a freezing point of water. So 0 degrees Celsius, zero is not something 0 degrees Celsius was not something which was naturally existing. You defined it. You said that this particular temperature, I will be calling it 0 degrees Celsius. Maybe on Mars, right? Maybe on Mars, if the water freezes at 10 degrees Celsius, then that 10 degrees Celsius, I will take it as zero. Right? So 0 is not absence of heat. 0 is freezing point of water. It is just a reference point. Okay. And in Kelvin, what is 0 degrees Celsius?
36,
No, in Kelvins,
32, minus
273.
273, right? 273 Kelvin. So 0 degrees Celsius, 0 degrees Celsius is equal to 273 Kelvin. But what is then 0 Kelvin? What is 0 Kelvin then? 0 Kelvin will be minus 273.
minus 276 Celsius.
Right. And you know what? You cannot make anything colder than minus 273 degrees Celsius. There is no temperature less than that. Okay. Like if you'll talk about on the upside, right? We have 1,000 degrees Celsius, we have 10,000 degrees Celsius, we have 50,000 degrees Celsius in temperature. So on the upside, there is a very high range. Okay. You can go to 50,000 degrees Celsius. But on the lower side, the minimum that you can go is 273 degrees Celsius, minus 270 minimum. Beyond that, you cannot make anything any colder. Why you cannot make anything any colder? Because there is
There's no
no heat present after that. Okay. There is no heat present after minus 273 degrees Celsius, and that point is taken as 0 Kelvin. Okay. Now tell me, when I am moving from 10 degrees Celsius to 20 degrees Celsius, is the heat in the system becoming twice or not?
Yes.
Yes.
If I'm moving from 10 degrees Celsius to 20 degrees Celsius, then the heat is becoming twice, right? If I'll talk in terms of Kelvin, what is 10 degrees Celsius?
283 Kelvin.
2730.
No. In Kelvin, it will be just 273 you need to add.
Oh,
Right. So
yeah.
283 Kelvin. And similarly, what is 20 degrees Celsius?
293.
293.
Right? 293 Kelvin. So you were saying that when the temperature is moving from 10 degrees Celsius to 20 degrees Celsius, the thing is becoming twice as hot. But let's say if instead of using degrees Celsius, if I had used Kelvin, Will you see the same thing?
No.
So which one is correct?
Both of them is correct.
No, both of them is not correct.
283 Kelvin is also 10 degrees Celsius. No.
Right. But saying that when you're moving from 10 degrees Celsius to 20 degrees Celsius, the heat is becoming twice, that statement is wrong. Okay. When you're moving from 283 to 293, the heat is not becoming twice in the system. When I move from 100 Kelvin to 200 Kelvin, then the heat become twice. Okay. It means that when I'm moving from minus 173 degrees Celsius, okay, to I hope I've done the calculations right. When I move from minus 173 degrees Celsius to minus 73 Celsius, okay, then the heat is becoming twice. Not when you're moving from 10 degree to 20 degree. Why? Because here the reference point is correct. When you are in Kelvin, the reference point is correct. 0 Kelvin means zero heat. But when you are in Celsius, then the reference point is not correct. Okay, it's more or less like this. Let's say in India, we are saying that when you have zero money, it is actually zero money. Right? In let's say Pakistan, just for an example, I decided that I will call 10,000 rupees as zero money. Okay, so it means that if I have 10,000 rupees, I will be calling it zero money. If I will be having 20,000 rupees, I will be calling it how much?
1.
No, I will be calling it 10,000. No? If 10,000 is zero, then 20,000 is what? 10,000.
10,000.
Right? Then what will be 30,000?
20,000.
20,000. Right? So let's say this is what is happening in Pakistan. Just for an example again. And in India, zero means zero. Right? In India, someone's salary increased from 10,000 so to 20,000. Are they earning twice as much now? Is that correct? If in India someone's salary increased from 10,000 20,000, are they earning twice as much? Yes. There's very simple question. Yes. If you were earning 10,000 previous month, 20,000 this month, so you are earning twice as much. That's correct. If in Pakistan someone's salary changes from 10,000 to 20,000, are they earning twice as much? The answer is no. Why? Because in Pakistan, 10,000 means what? In actual rupees, it means what? 20,000. Right? And what is the meaning of 20,000 in Pakistan? If I convert it to rupees, what is 20,000?
10,000.
10,000.
30,000.
Like
We talk now.
1.4 times. Yes.
10,000 is 20,000. Zero is 10,000. So in Pakistan, when your salary is changing from 10,000 to 20,000, it is actually moving from 20 to 30,000. So here the difference is still 10K. But the salary is not becoming twice as much. It is just increasing by 50%. My point is, I know it's a little confusing and we will continue this topic later. But point being is where you have defined your zero actually changes a lot many things. Okay, especially the multiplication part. The difference here also is 10 Kelvin. Here also the difference is 10 Kelvin. Okay, the difference will always make sense. Here the difference was 10K. Here also the difference was 10K. Okay, but multiplication will not make sense. Here I was able to say that this was twice as much, but here when we are moving from 10,000 20,000, I cannot say it is 2x because 10,000 means 20,000 there, 20,000 means 30,000 there. So it is not twice as much. Okay, but again, forget about this example for now. I know it was a little confusing example that I took. Okay. But this is something that we will continue tomorrow. Okay. I will
So
try to
we,
take a better example and we will try to understand what do we mean by defining a zero or versus a naturally existing zero.
so you're saying like, it's incorrect to say the temperature is doubled.
Mm-hmm.
Uh,
But does
if
it change by 10 Kelvin? That's correct, right? Here
yes,
changed by 10 Kelvin. Here also changed by 10 Kelvin, right?
so we can say the temperature is doubled only when it happens in terms of Kelvin, because
Right,
it's an absolute calculation.
right. That's correct.
Okay.
So when it is moving
So,
from 100 Kelvin to 200 Kelvin, that is twice as much. But if it is moving from 100 degrees Celsius to 200 degrees Celsius, it is not twice as much. Because when you will convert it to the actual unit will be 100 degrees Celsius is nothing but 373 Kelvin. 200 is nothing but 473 Kelvin. 473 Kelvin is not 2 times of 373.
Okay, so even if it appears to be doubled, we have to
Right,
check the reference point
right,
to
exactly.
really check if
Right,
it's double or not.
right. So we need to first convert it to that unit, okay, where the true zero is defined, where the zero actually means absence. In degree Celsius, 0 degree Celsius, because it is not absence of heat. That's why the multiplication was not making any sense. Similarly, because in Pakistan, I was saying that 10,000 is, I'm assuming it to be zero. Zero in Pakistan doesn't mean zero money. It means 10,000 rupees. Because I have changed the reference point, now the multiplication will not make sense. Only the difference will make sense. Okay. But I will try to take better example tomorrow. Okay, and I will try to understand what the ratio and interval variables are. Okay. Any question on anything that we covered today? No, Stevie. We don't apply two sampling methods together. We try to keep it separate. There are other sampling methods also, although apart from these four, but these four are the popular ones that we use. But whatever you decide to use, if you decide to use stratified, you will use stratified. If you decide to use simple random, you will use simple random, but you will use only one. Mahi, the problem with the reference book or material is that there is no one single book that at least I have been able to find where all the relevant things are there. Okay, the things are very scattered in data science. Okay, so I have a few good books that I have referred to, but it is not one single book. Okay, so maybe I'll try to compile the list and maybe share it with you guys, the things which has helped me. But my recommendation will be not to start with them just right away. Uh, uh, let's wait for a few classes to happen, and if you'll then have time, maybe you can go through those books. But you will see that the course will not progress as per those books. No, no. So, Mahi, what you can do is, for revision at least, right? You can refer to the videos or the slides that I will be sharing. If you want to go beyond that, then yes, those books will be helpful. But whatever I am covering in the class, if you want to revise those, if you will try to take reference to any book, you will not be able to follow it. I can guarantee you that. Okay. So whenever you want to revise what we have covered in the class, try to take reference on the notes that I'm sharing or the notes that you are making in the class. Okay. The books are very detailed. Okay. So it's a good part also, bad part also. But there will be a lot of mathematics, there is a lot of other details which are there in the books.
sir, what topics will be covered tomorrow?
We will be covering one is we'll complete this part, the type of variables. Then we will be covering the data presentation part. I think I have already covered for some of you if I have taken Tableau, but I will quickly go through where to create what kind of chart. Will not spend much time on it, but some time. Then we will cover box plot. We will cover, I feel, yeah, we will cover measures of central tendency, that is mean, median, and mode. And then from there, we will move on to your standard deviation.
Okay. Yeah, thank you.
Okay. Cool. That's all for today, guys. Thank you, and I will see you tomorrow. Bye bye.
Thank you. Very informative class, by
You.
the way.
Yep. Thank you.
Thank you.
Yeah, good session. Thank you.
Thank you. Bye bye.